I'm very honored to be here to present my work, Democratizing Human-Centered AI with visual explanation and interactive guidance. Okay, so as we all know, AI has been ubiquitous. It's everywhere in our everyday life. For example, when I come here, I use a map. There's an AI to optimizing routes. When I browse online, there's AI text classifier to detect some spam messages and remove them automatically. When I shop online, there are also recommender systems to recommend different products. Even when I'm sending a message on my phone, there was a language model trying to auto-complete those messages. And more recently, there are also AI chatbots everywhere, so people can ask them some questions and get an immediate response. However, AI is not perfect. They are actually prone to mistakes, and sometimes those mistakes can cause serious harms in real life. For example, for content moderation, there are some false positive, false negative, or some biases issues. They can cause serious harm to different user groups, also people using those products. And more recently with the chatbot, there are also different types of new harms and new mistakes. For example, hallucination, malicious use, and harmful responses. Almost every week, we can see the news headlines about potential harms from those models causing to different people. So that motivates me to think about how can we create an AI system that people can trust and enjoy. And right now, many people focus on the AI system part. So thinking that it's a technical issue, maybe we can design better algorithm to make more trustworthy AI systems. For me, I want to focus on the people part. I think we should study how people use those AI systems, and we can design a system to empower people so they can trust and enjoy those AI technologies. So that leads to my research mission to enhance human-AI interactions through accessible AI explanation and human guidance. There are three interconnected parts of the thrust for my research or thesis. So I want to explain AI systems to humans and also empower humans to guide those AI systems. Eventually, I want to democratize the human-centered AI so everything is accessible to different stakeholders. And my work has resulted in many different publications across different fields like AI, HCI, and safety. And many of the work has won some best paper awards across different conferences. Also, my work is also recognized by AI scholars and JP Morgan PhD fellowships. And also many tools results in some resources, tools, and softwares. They're also being deployed at different companies, also hospitals. And also want to make sure my research is accessible to everyone. So most of my work is open source, and some of the projects also become very trending on GitHub. For example, Zijie Explainer have received over 1,000 GitHub stars. In this talk, I will focus on a few examples that exemplify my research thrust on explaining AI to everyone, guiding AI with human values, and democratizing human-centered AI. So my research really focuses on the interaction between humans and AI systems. I want to build bridges across those two entities. So one of the most fundamental bridges we can build is to explain AI systems to humans. Otherwise, people will not trust or use those AI technologies. So that leads to my first research thrust, to explain AI systems to everyone. So here, I want to explain AI systems to everyone, including different stakeholders, such as everyday users, students, and AI developers. Because different stakeholders have different needs when they're trying to understand AI. So we want to kind of tailor the design to help different stakeholders to learn about AI systems. So here are some few examples. So I designed systems to explain AI to novices, to policymakers, to practitioners. So here I argue there is no one-size-fits-all in terms of AI explanations. So we want to work with different user groups to identify their needs and tailor the tool and system to achieve those needs. To begin, I want to show the example of Zijie Explainer, so where we explain the model for novices to help them learn about AI concepts. So Zijie Explainer was published at this conference. So convolutional neural network is one of the most fundamental deep learning courses, models. So students learn those models in their AI 101 class. It's also popularly used in computer vision, natural language, and bioinformatics. However, I also heard many students struggle learning about CNNs. So they wonder why is learning CNN so hard, and what can we do to help them to learn about CNNs? So we conducted a formative study with interviewed with different instructors. So we learned that it's very challenging for beginners, especially it's very hard to understand the interplay between the model structure and also the underlying mathematical mechanisms. And in their courses, those instructors use visualizations to help students to learn about those concepts. We also conducted a survey with previous students to see what the main challenges. They also, with the findings, also echo the findings from the instructor interviews. So people really struggle understanding the connection between the math and also the structure, and also understanding the math behind the layers. There are some existing tools trying to explain different level of abstraction of CNNs. For example, some tool focus on the high-level explanation, and other tool focus on low-level mathematical mechanisms. They really inspire us to design a system to build a bridge between those two different level of abstractions to allow the user to use a transition to across different level of abstraction to learn about CNNs. So we developed CNXplainer, which is an interactive visualization tool people can use in their browser to learn about CNN models. Right now we give a demo. You can also try out the demo by visiting the link on the top right. Okay, so when user opens CNXplainer, they can see this view in their browser. So here we're running a CNN live directly in their browser. So we're doing image classifier to classify one image into one of the 10 classes. So the heat maps are the activation of different neurons. So user can hover over different neuron to highlight the connection between the previous neuron to that particular neuron. To learn more about how the pixel transforms into one particular neuron, user can click it to open the hidden view here. So we use animation to showcase how the convolution works. So with animation to show the window sliding process, how the model builds up the pixel and transforms the pixel into one particular neuron's activation. User can also go one step further to clip one pair of images to open the window view here. The user can also hover over to see how exactly the window sliding works. How do we apply the matrix multiplication at different stages and transform the features one layer by one layer. In the end, we also want to help a user to learn how we transform those high-level representation into the final prediction at one of the probability of one of the classes. So user can click one of the output neuron here, espresso, to open the flattened layer view. So here, user can also use interaction to see how we map the different pixel at the one last layer into one flattened layer. So we're very one high-dimensional vectors. User can also click the softmax to open the detailed mathematical formula to see how we transform the logics into the probability between 0 to 1. So user can hover over different neurons to also highlight their position in the mathematical formula. So we're really building the bridges between the model structure and also the underlying mathematical mechanisms to help a user to grasp the idea, the fundamental concepts of convolutional neural networks. And by having this tool, we want to study how effective it's helping people to learn about CNNs. We conducted a usefulness evaluation with 16 participants recruited from Georgia Tech. So we found out people really think our tool is easy to use, easy to understand, enjoyable to use. We also found out all the different tools are very helpful for them to learn about CNN concepts. During the interview, we also have some design lessons we learned from interacting with different participants. We found out transition really helps understand complex machine learning model concepts. And also animation is very engaging, it's very enjoyable. People like watching animation to help them to learn about the processes for the AI model uses. Also customization really engages users. So users can try out their own images to do some hypothesis testing and to learn more about CNN models. To really broaden access to those like AI technologies, we open source a CNXplainer, and we run everything using D3.js, also TensorFlow.js, using modern web technologies to run the model directly live in the browser. So users from across the world, they do not need dedicated servers or anything. You don't need an iPad or maybe like a laptop. They can visit CNXplainer and learn about CNN concepts. And once we release CNXplainer has become very popular, we have received over 7,000 GitHub stars, and we have over 300,000 visitors across the world. And in average, we have 400 visits daily with users using CNXplainer to learn about CNN concepts. And again, you can try out the tool by using the link on the top right. Okay, so here's one example of how we use visualization to explain AI to novices. So we can also, we found that interactive visualization is very helpful. So we want to take the lessons we learned to use visualization to explain AI to policymakers and practitioners. So for policymakers, we really want to know how people use those models in real life. To address that needs, we introduced DiffusionDB, the first large-scale text-to-image prompt dataset. So DiffusionDB, including 14 million image prompt pairs, were collected from Stable Diffusion users. So Stable Diffusion is one of the most cutting-edge text-to-image generative models. To collect those dataset, we scrape the Discord channels. So in Discord, user can generate the images by writing a prompt. So we can scrape the different channels. So we collect the dataset by using the timestamps, the usernames, the prompt parameters, generated images. And we structure them into a well-organized data set with 14 million images plus 1.8 unique prompts. We also have rich metadata with including hyperparameters. In total, they have 6.5 terabytes in total size. After having the data set, we want to study how people write their prompt and use those models. So we really want to use a name entity to identify what the most frequent phrases people use when writing their prompts. For example, here we identify there are some specific patterns people write their prompt. For example, some popular phrases like painting, and under painting there is oil painting, under oil painting there is intricate oil painting. So there is a hierarchy of the frequent phrases people use. There are some kind of predictable ways people write their prompt and use those models. And to really help policymakers to identify potential harm of those models, we also use named entity recognition to provide some evidence of some potential harm those models are causing. For example, people generate deep fakes of politicians like Donald Trump and Joe Biden. People generate misinformation, propaganda, and non-consensual pornography. So here's some evidence we provide. And here we focus on analyzing the data set from a syntactic level. We also want to do one step further to understand what's the semantic meaning of different prompts, also images. So we'll use a WisMap as a new tool to help the user to learn about different representation of prompts and images. So embedding is a very useful way to help people to learn about the representation of different data. For example, if we use a clip embedding, we can get like the multi-model embedding of the representation of the both text and the images. So we get the high-level representation of both text and images into the one space. So people oftentimes visualize embeddings by scatter plot. It's very popular across different domains like chemistry, social science, and machine learning, but it's very challenging to understand what's going on into different clusters because it requires a lot of human labor to look at data and try to annotate different clusters. So we want to address that needs. We introduced WisMap to help AI practitioners to visually explore and explain the embeddings of a large data set. So here's one example of using WisMap on explaining the prompts and images from Diffusion DB. So here we have 3 million data points directly running in user's browser, so it's very scalable. Here you can see some different rectangles that highlight the topics within different neighborhoods of the embedding distribution. So here user can click the points to show the different both images and prompts. So the blue are the prompts and the red are the images. User can smoothly zoom in and zoom out. You can see you can hover over different points across 3 million data points to see the detail of different prompts and also the images. So here's more like a fantasy cluster. So many people generate a fantasy about prompts, also the images about fantasy concepts. And here's a more realistic cluster. So people have some celebrity images and some real people's images. So people can use this tool to explore the large-scale data set with embeddings. User can also focus on distribution of those embeddings. For example, we expect we'll see the same distribution of prompt and images, but WisMap review is not the case. There is some mistake and some limitation for those text-to-image models. User can also smoothly search different keywords. For example, here's a cat cluster around on the button, lower button right area. There's also a movie cluster on the even bottom area. So user can explore different clusters to understand what's going on and how the model make prediction, how the model represent different images and also text. And we really use modern web technology to make everything as smooth as possible, and everything is on device. For example, use Stream API to stream over 3 million data points directly in the browser. Use WebGL to render millions of data points. Also use Web Worker to make everything parallel.
See if you can speak louder so that the audio can pick up better.
Okay, sounds good. Yeah. Okay, so here's some examples where explain AI to different stakeholders. We really tailor the different visualization to meet the needs across different stakeholders. For example, for novices, we really explain the AI concepts. And for practitioners, we really explain the nuanced explanation. And for policymakers, we provide real-life usage and impacts. So here we're building the first bridge across the humans and AI systems. You may wonder, then what? We would argue explanation is not the end, but rather a means to the end. What more importantly is we use the explanation to improve our AI systems. So that is to my second research thrust, to empower the humans to guide AI systems with human values and knowledges. So similar to the first one, we also focus on different stakeholders. So we focus on the people who create those AI systems and also the people who are impacted by those systems. To begin, we can look at one example, how we can empower domain experts and AI practitioners to fix AI errors by model editing. This work is collaboration with Microsoft Research and NYU Langone Health. This work is published at KDD in 2022. As we mentioned, UI is ubiquitous, so everyone's using AI. However, it's not that ubiquitous in high-stakes domains, such as healthcare domains. And one of the obstacles is doctors do not understand how those models make predictions, so that they cannot trust those models. Recently, we have seen huge strides in the research. People are ready to make intelligible machine learning model. We have different techniques to explain those AI models. You may wonder, okay, problem solved, right? So people can use those models. Actually, we see new problems arise after interpretability. So right now, after we can explain those models, doctors still cannot use model, because they review the explanation, those models pick out some harmful behavior from the training data sets that do not align with doctors' values and knowledges. As you can see, by having interpretability, we only solve part of the problem. So what is more important, we want to use interpretability to fix those models. So here I will show a real-life example how the explanation reviews some harmful patterns in the dataset and how we can fix it. Before that, I will give you some background for the model we're focusing. It's called Explainable Boosting Machine Model, or called EBM. It's one form of generative additive model, so similar to random forest, but it's a glass box model, so it's inherently intelligible. So people can use those plots to easily to visualize and to understand how the model makes predictions across different features. Also, it's additive, so we have one plot for different feature, and in the end, we then add them together. And all different features are independent, so we can train different features independently. In the end, they can all add up together. So here's more detail about particular data set we're using. So we're trying to predict the likelihood of someone with dying from pneumonia. So on the x-axis, we have the age. On the y-axis, we have the risk of dying from pneumonia. We noted there is some sudden increase of risk around the patient around age 68. So we have some hypothesis, maybe some retirement, maybe the change of insurance plan to have higher risk. Also notice a new sudden increase around 85, maybe there's some conservative treatment for older patients. However, we notice there's a mysterious drop at the end. So for patients over 100 years old, the model actually predicts they have lower risk. It does not align with any knowledge and values from the doctors. And if we deploy those models in real life, they can cause serious harm because people might not get the care they needed. And how can we fix it? So one simple way to do it is to change the parameters for this model. We can manually assign a risk score for patients over 100 years old. That's what we call model editing. After talking to many people at Microsoft, we identified their real needs model editing. For example, people want to fix some undesirable behaviors, to remedy some mistake in data set, to combat some fairness and biases issues, also maybe the compliance and regulations. To help the different practitioners to easily to edit their model parameters, we introduced Scan Changer, the first interactive visualization tool to help a user to do model editing on EBM models. Also, our tool is open source, and we have a demo you can visit on the top right link. So here we have a demo for this tool. So here I'm using the same data set of pneumonia risk prediction. So on the x-axis, we have the age. On the y-axis, we have the risk of dying from pneumonia. So user can change different feature by using the drop-down menu to select different features. User can see we have different visualization design for different feature type, for categorical feature, or maybe the interaction between different features. For example, interaction between a continuous feature and with a categorical feature, or maybe the interaction between two continuous features. Okay, let's go back to the age features. So user can click the drop-down menu to go back to age. So here are some errors we want to fix. So user can easily drag around to zoom in, zoom out to see the details of the bins and also risk score of different user groups. So user can zoom in on this pattern and select the different region of the older patients. Here we can apply different editing tools. For example, we can use the alignment tool to align the risk score to the left neighbors so they have a similar risk score as someone who is maybe 20 years younger. You will notice on the right-hand side, we have the accuracy performance panel. So we show the real-time performance of the edited model to help a user to know what the consequences for their editing. User can also click the feature panel to see some correlated feature for that particular selected regions. So you can see, so gender is one highly correlated features, which makes sense because the females tend to live longer. So we tell the user, so if you do the edits, you have more impacts on female patients, which is okay in this case. We'll click the checkbox, check item to commit these edits. Okay, so let's look at the different regions we want to edit. For example, there is a sudden increase of around 85. We can zoom in into that particular region and apply the same editing again with a different editing tool. For example, we select the different bins across different regions, then we can apply the interpolation tools. Before that, we can also test like the feature correlations to see what's an other correlated feature for the particular region. They all look good to me, so we can keep editing this feature. For example, we can click the interpolation, then we can interpolate the whole bins by using a smooth increase of a risk score from age 80 to 85, so which aligns better with knowledge of doctors' knowledge and experiences. And also inspired by the Git systems, we also version control everything. So when users doing the one edits or doing one Git commits, users can also write their own commit messages to document why they're doing the edits and how they're doing the edits. User can also confirm the different edits by check the thumbs up button. To ensure safe editing, also allow users to undo and redo different editings. User can also use the shortcut Command-Z, Command-Shift-Z to undo and redo, so user they can experiment different editing strategies. User can also go back to previous snapshots of different model versions to go back to see the different model editing snapshots. In the end, user can export everything into a game changer model file, so they can deploy this model using Python, or maybe can continue editing in the future with game changer. By having this tool, we want to also evaluate how the tool works and how do people do the model of editing. So we recruited 7 participants from the GitHub issue boards, so their experience with EBM models. So we use a long application prediction scenario to let them try out editing. We have learned some interesting findings from the studies. For example, first, we found that model editing is actually very common in practice. So people really notice some very unpredictable and harmful behavior of the models. People use some different forms of model editing. For example, to enforce monotonicity or to smooth out the shape functions. Participants also really appreciate our tool fitting into their workflows. For example, people can use Game Changer directly in their computational notebooks. So people really appreciate they can directly using the tool in their existing workflows. People also really like the idea of model documentation, because by documenting why they're doing the edits, it's really helpful for them to collaborate with different auditors when they review the models. People also find out it's very easy to use our tool, collaborate with different stakeholders, because they can show the visualization, so maybe different people can edit the model together. We also found out there are many diverse ways to edit different models. For example, there's one particular feature in the shape function, so different people, you apply different editing tools across different regions of that feature. For example, some people align to the right, some people want to smooth out the whole shape function in the middle region, some people want to make the whole graph monotonic. Some people, they are free to editing. They only edit after talking to some financial experts. So we can see different people have a different way to do the model editing. There's some impact how I think about the AI alignment and for large language models. So whose value should we align to the inference findings for future research works. So here's one example of how we can empower the AI practitioner and domain experts to fix AI errors by model editing. We also want to empower the other people, for example, the people impacted by those AI systems, to alter those model decisions through other different approaches. So we empower them to guide those AIs with their human values. So the existing way to do that is called algorithmic recourse. So the way to provide end users with different ways they can do to alter the unfavorable machine learning decisions. For example, in a loan application scenario, maybe the bank rejects the loan application, so they also provide some suggestions. For example, if your income were 50K higher, your application would be approved. So this is one we call the counterfactual explanation. So you have different input, you may have a different output which is more favorable. But oftentimes those suggestions are not very actionable. It's very hard for me to increase my income by 50K suddenly. So there is also new research on actionable algorithmic recourse, for example, to minimize the feature changes, to try to prioritize high variance features to provide multiple plans so people can choose from. However, existing world really assumes that developer knows what constitutes actionability, and that's the same for all the end users. We would argue actionability is actually personal and subjective. They vary from one user to a different user. Maybe for one user, they're okay with a smaller loan. For other users, actually it's easier for them to change their FICO scores. But how do we return the agency back to the user to empower them to fine-tune, to choose the best recourse plans? To do that, we introduced the preference of well algorithm using adapting integer linear program. So we use like a new algorithm to generate the optimal solution with the constraint specified by the different users. To help the end user to specify the different preferences and also constraints, we also introduce the interface to help them easily use those tools. For example, in Gantt Coach, user can use to see the contribution of different features. They can play around with different feature values to see their contribution to the final prediction score. They can change the difficulties of changing one feature by clicking the button. They can also change the subtle range of the contained features. After setting the preferences, user can click the regenerate button. Then we generate the optimal recourse plans that meets the preferences specified by the users. In the end, user can save the different plans into their bookmarks so they can apply those changes in real life and maybe apply the loan again in the future. So, yeah.
Sorry to interrupt you again. So the committee member has a time listening, I think because of the room audio.
Okay.
Can you try using, are you using your laptop's microphone?
No, I'm using the
Can you
room.
switch to your laptop's microphone?
Okay, okay.
Speaker. So basically turn off the room's speaker and microphone.
Oh, let's see.
Let's see if the audio is better.
So I'm not joining on the Zoom. Maybe I can join.
Zoom is fine.
Okay.
So that means you just use the video, but for all audio, go through your laptop and see if that's better.
Sounds good.
And then say something. After you switch, say something.
Okay.
See,
I'll have to do that.
you can turn off the speaker also.
Yeah. Okay, is this better? Can you hear?
You need to say more. See.
Okay. Okay, so we use a new.
Oh, okay, good. Yeah, much better.
Okay, sounds good.
Okay, so now let's see for the committee member. So that means all audio is routing through Jay's laptop. So that means the room wouldn't hear what you say. Yes.
Okay.
Okay, I think we're good.
Sound a little far away, Polo, but yeah.
Okay, good. Yeah.
Okay,
you can-
sounds good. Sorry. Okay, so here, so we have some examples how we can help the domain experts and people impacted by AI assistant to align the AI assistant with their knowledge and values. So here, we're building the bridges between humans and the AI assistants. We're not only explaining AI assistant to the humans, we also empower humans to guide the AI assistant with their knowledge and values. But they are only useful if the people can adopt those human AI-centered AI practice. So that leads to my third research thrust, to lower the barrier to adopting those human-centered AI practices. So I want to focus on the workflows. How can I make it easier to make it accessible for everyone to adopt those human-centered AI practice into their workflows? So here I noticed there are some existing workflow, different stakeholders interact with AI assistants. For example, people use ChatGPT, use Google Doc when they interact with the AI assistants, when they develop systems, or use AI models. So instead of creating new AI assistants or new resources, new workflow, people have to learn, adopt. We can directly integrate our human-centered AI practice into existing workflows. So we have a lower friction to adopt those human-centered AI practice. So here we provide one example we call Farsight. So it's a collaboration with Google researcher from Google Research, the publisher Kai, also won the Best Paper Honorable Mention Award. So here we have an in situ tool to help a user to be more mindful when they're prototyping for AI features. Nowadays, developing AI features is very easy because with the help of large language models, people can use them to implement different features. And also with the easy-to-use AI prototyping tools, such as Google AI Studio, Workflow, and GPT Playground. So everyone can easily, by writing prompt, to create a new AI feature and new AI apps. While developing AI feature becomes easier than ever before, it's also become much harder to ensure responsible AI. There are two main challenges. For example, with diverse capability for large language models, there are also new ways they can cause harm to different people. And also with newer, more spectrum of AI developers, many of them do not have experience in AI or responsible AI, so it's harder to ensuring responsible AI. And I think we can see there's an example of news articles of the AI causing harm to real life. People focusing on the RAI practice in the later stage of their workflow. People think about the RAI issues when they develop the demos, when they're deploying the products. We argue we should think about AI issue earlier, so people should think about AI issue when they write their first prompt. There are several advantages. For example, we can prioritize RAI issues. We can take actions early because there are more stakeholders in the early stage of the workflow. We can also educate a broader audience about the RAI. To help users to think about how we can design a new tool, maybe a widget, to think more, to remind them about potential harms, we conducted a formative design study with 10 AI prototypers recruited from Google to help them to get some idea of how can we design the tool to help users to think about potential harms during AI prototyping. And gather the feedback and design ideas, we introduced Farsight, interactive tool to help users to envision different potential harms during AI prototyping. You can also try out the tool by visiting the link on the top right. So here's a demo of this tool. Here's a typical web interface. People write a prompt, they can run the prompt. You will notice on the right-hand side, there's a blue icon. It's a Farsight widgets. They're monitoring to see how you write the prompts and to alert you if the prompt is kind of dangerous. For example, here I'm writing a prompt for legal brief writer to generate legal brief. After running the prompt, you can see the blue icon turns red to alarm the user about potential harm for this prompt. And the user can click it to open the right sidebar. On the top, we have a real AI instance. We use an embedding for the prompt to surface similar news articles from over 3,000 database to see what's a similar news article that's similar to the prompt about the AI instance. For example, in this case, people can see some news headlines about like a lawyer getting caught by using ChatGPT to generate different like law cases. Below that, we have potential use cases. So here we use AI to envision different use cases and harms can cause by using this prompt. We also use AI to classify them into different use cases. For example, intended use cases, how different people can use different this tool to generate different law cases and also potential harms. And also misuse, so here the bad actors can intentionally do bad things with this prompt. For example, scammers can generate a fake legal brief to scam other people. And here the victim of scam may lose money because they try those like lawsuits. Okay, let's try a different, more benign prompt. For example, we can generate a joke writer. In this case, Farsight remains blue, so because we do not find very relevant news articles about the harm of writing jokes with AI. However, we can still use AI to envision potential use cases and harm for those joke writers. For example, politicians can use this prompt to generate some potential jokes and to connect with the voters. One potential harm a politician may lose the election if the AI-generated content being offensive. Okay, let's look at a different prompt. So here I'm looking at different prompt maybe from translating English to French. After running the prompt, we can see there are some relevant news articles. Then to learn more, user can click the blue icon to open the harm envisioner. So here I have a more human AI collaborative approach to envision more harms, use cases, and stakeholders. To begin, we use AI to envision to get the summary of the prompt. So here's to translate a sentence from English to French, which looks good to me. I will click yes. Then we have the interactive tree visualization to showing the use cases of that particular prompt. So user can feature to look through what's interesting to the feature with the users. For me, I'm interested in doctor used to translate medical records. So user can edit the different use cases or change the category of different use cases or maybe delete the use cases. And user can click one button to envision the stakeholders within that use cases. And also the harms can cause to different stakeholders within that use cases. For example, patients may receive incorrect treatment due to inaccurate translation of the medical records. So here they're generated by AI. People can also read the severity of different harms by reading the fire button. Maybe they're very severe, we give 3 fires. User can also change the different category of different harm. By default, we use AI to predict the harm tag category using the harm taxonomy from Google. But people can easily change them. People can also go through to generate more different harm for the same stakeholder. Maybe a patient may lose trust for the doctors if they believe the medical records are being translated correctly. Maybe doctors also may lose a job if the translation being inaccurate. Maybe hospitals have liability. Maybe family and friends also lose trust to the doctors. Then people also can change different stakeholders and regenerate different harm. For example, society at large, the Farsight generates some potential harm. Maybe society may face increased healthcare costs due to mistranslation of medical records. In the end, after envisioning and brainstorming different use cases and harms, people can download everything into Markdown file so they can go through the different use cases and think about mitigation strategies in their team meetings. To really help to different people to adopt Farsight, we make it easy to use Farsight by integrating into their existing prompting workflows. For example, many people prompt using those interfaces like Google AI Studio, so we provide a Chrome extension so people can directly use it with the Google AI Studio today. Well, for people who like to prompt using Jupyter notebooks, we'll provide computational notebook widgets so people can directly use Farsight directly in computational notebook environments. To study how effective is Farsight, we had an evaluation study with 42 AI prototypers recruited from Google. So they have different familiarity score with our AI, responsible AI, also different familiarity with prompting. So the first research question we want to ask is how does Farsight affect users' ability and approach to identify potential harms? So we want to compare our tool, Farsight, with existing approaches. So for our tool, we have two variants, varying the inclusion of harm envisioner, the human AI collaborative approach to envision harm. And for the control group, we use a state-of-the-art of the most popular framework people use to identify harm, developed at Microsoft, and also harm taxonomy from Google. So people can think about different workflow, to think about different harms, different use cases, and also different types of the harms. And to really study the impact for Farsight intervention on people's ability and approaches, we designed a pre versus post between subject study. So we recruited participants, we randomly split them into different random groups, in 3 groups. So at the first activity, we show them a prompt, email summarizer, and allow them to envision as many harms as possible, as severe as possible. Then we write down that prompt in a Google Doc. On the second activity, we apply different intervention strategies, Farsight and also the control group, the envision guide. In the end, we take away the intervention and let them envision harm again on their own independently on a different prompt, article summarizer. Then we collect all the harms again. In the end, we have interview to reflect what have changed, how do they feel about the student tools. We also recruit 7 RAI experts to read the severity and the likelihood across different harms we collected from the study. After analyzing both the rating scores and also the transcript of interviews, we have several findings. For example, I found a user envision more harms after using Farsight. So after using Farsight, people can envision more harm on their own. It shows educational value of Farsight. By using Farsight on their own, people can learn how to envision harm, how to envision even use cases and stakeholders. However, there are no significant changes for severity and likelihood for the envisioned harms. We also found out Farsight users become more aware of end users. By analyzing how people envision harm through the transcripts of the think aloud protocols, we identify 6 patterns when user envision harms. We found out after using Farsight, people really pick up ways to focus on usage-driven to indirect stakeholders or maybe cascading harm, so the harm caused by other harms. For the second research question, we want to study how effective is Farsight in assisting users in envisioning potential harms. So here we think of it as an assistant tool to help us to envision harm while developing new AI features. So we designed a within subject study. So we recruit participants and randomly shuffle them into 4 different groups. Then we apply both interventions. And also shuffle the order between 2 different interventions. And in the end, we have interview to let them compare which is better and which is worse and what works or doesn't work. We found out Farsight really helps users envision more harms, so we can envision more harms while we're using Farsight compared to the baseline. Also, similarly, there is no significant difference for severity and likelihood. Also, Farsight sparked users to think beyond immediate harms. By surfacing those AI-generated harms, people can think one step further to think about the interplay, the interaction between different stakeholders, or maybe the harm caused by other harms. So it's very interesting. For example, here there's 2 different stakeholders. Participants think about how different stakeholders might interact with each other. That might cause a harm from one stakeholder to different stakeholder. We also found out Farsight participants also Farsight inspire users to consider mitigation strategies on their own. So people think about how can they implement some different processes to mitigate those harms. Also, maybe some participants also say they will stop implementing the feature because the harm is too severe. By comparing Farsight and the control group, also find out Farsight is useful, also preferred over the control group. So people find it more easier to use Farsight to envision harm, also more enjoyable to use, and they will use in the future. Okay, so here's to have an overview of my research. So we not only explain AI assistance to humans, we also empower humans to guide AI assistants. We also made it easier to adopt, so everyone can use those human-centered AI practice in their work. And I'm very glad to see there are also a lot of impacts of my research on society, academia, and industry. For example, Think Explainer is helping over 300,000 people learn about Think across the world. Many visualization tools have been demoed and used at Apple and Google. And my game changer work is being used by the doctors from NYU Hospital, also deployed on Microsoft, also integrated into Microsoft's machine learning library. Also, many papers won Best Paper Type Awards across different conferences. Also, my work is being recognized by Apple Scholar Fellowship and JP Morgan PhD Fellowship. Looking back at my research, I really learned a lot of lessons across different research swaths. For example, when designing tools to explain AI systems to different humans, we noticed that different users have different needs for different stakeholders. We really need to apply a human-centered approach to tailor the visualization, explanation, or the communication strategies to explain AI to different stakeholders. We also pioneered on-device computation for scalable and tailored visualizations to explain AI concepts. And for guiding human, for empowering human to guide AI systems, we noticed like actionability and agency are the key needs. And then we introduced the first of the kind tool to help users to address those needs. We'll also introduce the transformative paradigm to focusing on the workflows, to integrating human-centered AI practice into existing workflow to lower the barrier to adopting those practices. Looking ahead, I want to keep working on those directions to empower the human-AI collaboration, also interactions. I want to keep working on easily adoptable human-centered AI. I want to think more about the workflows. How can we integrate more practice into different workflow across different stakeholders? How can I have more human-AI collaborative way to do like the AI safety testing? Maybe have more easy to use interactive tools, help different people across different backgrounds to help their voice heard in AI safety. Recently, I've also interested in on-device computation. We can leverage our on-device techniques to run different learning energy models in the browser on the edge devices, so better privacy and lower latency. So in the future, we want to work on the easier development of those tools we can design for ubiquitous AI. Finally, we also have interactive AI alignments. So think about how can we define an AI policy or AI rules for different user groups. Maybe have interactive approach, so different people can easily specify their rules or their AI policies. Maybe have automatic approach, so we can learn from usage-driven logs, user policy. We can automatically generate those policies to meet the user's needs. And with the breakthrough of the interoperability of large language models, maybe we can also, similar to Game Changer, we can directly change the parameter for large language models to influence or to tailor like the behavior of those models. And I'm very happy I can keep pursuing those research swaths in my future. So I will become as a research engineer at OpenAI. I will keep working on those research directions. And we're also happy to advocate for a human-centered approach across different workflow, across different development of the new cutting-edge AI technologies. And look back at the journey, I'm getting very emotional when making the slides. So my 5-year PhD is my happiest time of my life. I've made so many friends at Georgia Tech and at different companies. I have so many projects. I learned so many new things and new skills, collaborating with so many amazing people. I really appreciate my advisor, Polo. He's providing such a supportive environment for me and giving me the freedom to pursue my interests. And also, it really takes a village to raise the PhD students. I cannot be where I am right now without the help, with all the mentors I have, with all the collaborators, and with all the friends. So really appreciate everyone. All right, thank you. So that's all the presentation of my thesis defense on democratizing human-centered AI with visual explanation and interactive guidance. Thank you so much for your attention.